Hi everyone, in today's video we're going to be discussing the study guide for quadrilaterals and coordinate geometry. First, to prove it's a parallelogram, the same pair of opposite sides have to be both parallel and congruent. So for example, AB has to be congruent to CD and AB has to be parallel to CD. So AB is congruent to CD, and AB is parallel to CD. Or you could do the opposite. BC is congruent to AD, and AD is parallel to BC. So AD congruent to BC, and AD parallel to BC. So the same pair of opposite sides has to both be parallel and congruent. Next, opposite angles of a parallelogram are congruent. So for example, if I have a parallelogram here, ROCK, if this angle is 70, then the angle across or opposite also is 70. So angle C would be congruent to angle R. Opposite angles of a parallelogram are congruent. Next, we have consecutive angles in a parallelogram add to 180. Remember, the word consecutive means next to. So, for example, angle K and angle C are consecutive. They're next to each other. So if I make this x, x plus 70 is equal to 180. And therefore, x is going to be equal to 110 degrees. Consecutive angles are angles that are next to each other in a parallelogram add to 180 degrees. They're supplementary. Next, we have to find the perimeter of a rhombus, cut the diagonals in half, and use Pythagorean theorem to find the side of a rhombus. So remember, the diagonals are perpendicular, forming 90-degree angles, and they also bisect each other, meaning PT is congruent to TR, and TS is congruent to QT. So for example, if I had RP as 18, the length of this diagonal, I would cut it in half and I would get 9. So PT is 9 and TR is 9. Then if I had SQ was, let's say, 10, I would divide it by 2 and get 5. So ST would be 5 and TQ would be 5. And then notice again I have a right triangle. So what I would have to do, I can redraw it. This is 5, this is 9. I would be looking for the side length of the rhombus, and I would be using the Pythagorean theorem. C, remember, is my hypotenuse across from the 90-degree angle, so it would be 9 squared plus 5 squared is equal to C squared. 9 squared is 81. 81 plus 5 squared, which is 25, is equal to C squared. 81 plus 25 is 106, is equal to C squared. Take the square root on both sides. So C would be equal to radical 106. So that's the length of one side. However, you're looking for the perimeter, which means you have to add up all the sides of the rhombus. So there are 4 sides, so that would be 4 radical 106. Next, remember, angles in a quadrilateral add to 360 degrees. So here's a quadrilateral. I would add x plus 56 plus 64 plus 110 is equal to 360 degrees. I would use my calculator and add 56 plus 64 plus 110, and that would give me 230 is equal to 360. Subtract 230 on both sides. X would be equal to 130 degrees. Angles in a quadrilateral add to 360 degrees. Next, we have quick reminders that distinguish a rhombus between a rectangle. A rhombus has perpendicular diagonals, and a rectangle has congruent diagonals. These are two properties that you should be very familiar with. And finally, we have steps to complete a coordinate proof. Remember, to prove that something is a parallelogram, rhombus, rectangle, or square, we use the distance formula 6 times. The distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. To prove something is a parallelogram, you would use it 6 times and say that the two pairs of opposite sides are congruent, but the diagonals are not. In a rhombus, you would prove all 4 sides are congruent, but the diagonals are not. At a rectangle, 2 pairs of opposite sides are congruent, but the diagonals are also congruent. And a square, all 4 sides are congruent and 2 congruent diagonals. For a trapezoid, you would prove that one pair of opposite sides are parallel and the other pair is not by using the slope formula 4 times. To prove an isosceles trapezoid, you would use the slope formula 4 times to prove one pair of opposite sides are parallel and the other is not. And you would also use the distance formula twice to prove that the non-parallel sides are congruent. Lastly, to prove triangles, you would be using the distance formula 3 times. For isosceles, you would prove that 2 sides are congruent. Equilateral, 3 sides are congruent. And a right triangle, you would use the distance formula 3 times, and then use the Pythagorean theorem to prove that the triangle does satisfy the Pythagorean theorem, therefore is a right triangle. And don't forget, at the end of every coordinate geometry proof, you must make a big conclusion statement and sum up the question.